Let's finally take a look at an example of using elementary row operations to take a matrix A and put it in either an REF form or find its rank or determine the RREF form of the matrix. So here we go. The first thing I'd like to say about matrix A here and what we're going to do with it is, if you'll notice here in part A, it says find an REF of A. And I really want to put some emphasis on the word "and" there. That is to say, REF A is not unique. What do I mean by that? There are many possible REF A's, and we just want to find one of them. Find one of them. That'll suit our purposes just fine. Remember that in part B, to actually find the rank of A, by the way, the definition of rank A, mistakenly by some students, is thought to be the number of non-zero rows in A. And if you look at A doesn't have any zero rows, and you might say to yourself, well, the rank of A must be 3, but that's actually not the definition of rank. The definition of rank is the number of non-zero rows in any REF form. So we can't actually call out the rank of A until we do part A of this problem. So rank A requires an REF A. And then the last thing I want to say here, when they ask us find the RREF of A, the reduced row echelon form for A, that is unique. This is unique. What do I mean by unique? I mean there is only one possible RREFA. So there's no two ways about it there. So let's get started. How are we going to do this? So how to find REFA. It's very, very systematic. So what you're going to do is, start in row 1 and find the first non-zero value. Okay, let me copy this guy here really quick. Duplicate. Here we go. Okay, so this is A, and this is our current row number 1, and this is the first non-zero position in that row. This is called a pivot position. This is a pivot position. Since it is 1, it is also a leading 1. Excuse me. Okay, so now what are we going to do? So we're going to now use this pivot position and EROs, elementary row operations, to zero out all values below the pivot in this same column. So what are those values? That actually corresponds to these two in red that I want to get rid of. I'm going to use EROs to eliminate that. So how can we do that? Well, if this was a system of equations and not just a couple of rows, I might use elimination, and I might do something like take that first row and multiply it by 2. That is to say, I might do something like 2 times row 1 minus row 2, and that would look like this. If I 2 times 1, 1, negative 1, 1, 1. And then if I take the second row, 2, 3, 1, 0, 4, and I subtract, I want to know what I'm going to get. Well, that gives me the same thing as 2, 2, negative 2, 2, 2, and 2, 3, 1, 0, 4. And we're going to subtract. And that'll give me 0, negative 1, negative 3, 2, negative 2, and that would be my result. And so what we're going to do is get an equivalent form. We want to leave our row with our pivot alone. That's 1, 1, negative 1, 1, 1. And then we're going to take 2 times row 1 minus row 2 and make that our new row 2. That's what that notation says. And you notice I put that next to row 2, so it's clear that that's where I'm doing that operation. And that result, this guy here, is what's going to go in this row. So that is 0, negative 1, negative 3, 2, negative 2. Now I'm also going to take 3 times row 1, and I'm going to subtract row 3 because my pivot position is a 1, and underneath that in row 3 is a 3. And if I do 3 times the top row and subtract the bottom row, I'll get a 0 in that position right here. So that's going to be, let's see, let me just do the arithmetic here. That's 3, 3, negative 3, 3, 3, and 3, 5, 3, negative 1, 5. And we're going to subtract, and our new row 3 is going to be 0, negative 2, negative 6, 4, negative 2. So let's see here. That's my new row. Sorry, my new row 3. Excuse me if I said row 2 there. That's 0, negative 2, negative 6, 4, and negative 2. And how we got that was I took 3 times row 1, I subtracted row 3, and I made that my new row 3. Now, when I said we're going to be using EROs, in the previous video I said there's only 3 EROs. Swap any 2, permute or swap any 2 rows, add or subtract any 2 rows together to make a new row, and multiply any row by any non-zero value. Well, it actually turns out that I'm doing multiple EROs at once, right? I'm multiplying row 1 by 2, and then I'm subtracting, or I'm multiplying row 2 by 1, I'm multiplying row 2 by negative 1, and I'm adding them together. So this is kind of a macro of EROs. I'm doing multiple EROs at once. There's smaller pieces to a larger operation that I'm going to do. So that is my first step. Now, this is sort of a little intermediary step here. And then I would say, then clean up. Now, what do I mean by clean up? I mean, it's really nice to work with positive numbers, and there's some common factors in here. So what I'm going to actually do is, leaving this first row alone, 1, 1, negative 1, 1, 1. If possible, I would like my leading positions to be 1s, or at least positive. So what I'm going to do is I'm going to do a negative row 2, and that's going to be my new row 2. Now, again, I've said this before. When I talk about row 2 now, in this third step, I'm no longer talking about this row 2. I'm talking about this row 2 down here. This is my row 2 when I talk about this operation. Excuse me, that was not correct. I'm talking about this row 2 up here. Now, again, whenever I talk about this notation for EROs, I'm always referring to the matrix in the previous step. And so that's going to give me 0, 1, 3, negative 2, 2. And then I'm actually going to do negative 1/2 row 3 is my new row 3. Or effectively, I'm going to factor out a negative 2. And this is going to be 0, 1, 3, negative 2, 1. And that is my new row 3. Okay, so once you've done the finding your first pivot position, as I did up here in purple, and then clearing out these 2 values, which I've done down here, clearing out not just necessarily 2, but every value underneath that leading pivot position. Again, here's my leading pivot position in the top row. Once you've done that and done a little bit of cleanup here, the next thing you want to do is step 2. Move to the next row, find the pivot position, or first non-zero value in that row. And again, when we read this, we're reading it from left to right. And repeat the process. So let me copy this here. That will look like this. So what do we have here? We're now working in our second row, and in the second row, this is now my pivot or my leading one position. And so I'm going to use that position specifically to clear out all the values underneath it. And here there's only one value. Now, it's really, really important that you do that, so please pay attention. And I'm going to try to do my best to annotate this without jacking it all up. To eliminate this position, we could actually either use this position way up above in row 1 or this position by simply subtracting. You'll notice that if I do row 2 minus row 3 and make it my new row 3, I will for sure get a 0 in this bottom position. But I will also get a 0 in that position if I do row 1 minus row 3 is my new row 3. And that was supposed to be a subtraction sign right in there. Hold on a second. Subtract. Either one of those will work, but while this one minus this one will give me a 0 in this position, here's the kicker. This one minus this 0 will make this position a 1 again, and I will undo the work I did in the first step. And that's why it's terribly important that once you clear out this column, you move to your next pivot position before you move on in the next row. Otherwise, you will begin to undo all of the work that you've already done, and you will chase your tail quite a bit here. So let me say that this is not what we want to do. And I want to erase a lot of this arrow stuff here because it's really crowding the problem. So here we go. We are going to stick with this operation right here. This is the operation we're going to do. Row 2 minus row 3 is my new row 3. And if I write that out, that's 0, 1, 3, negative 2, 2, 0, 1, 3, negative 2, 1. And we're going to subtract. And that's going to give us 0, 0, 0, 0, 1. And so this is row equivalent to 1, 1, negative 1, 1, 1. 0, 1, 3, negative 2, 2, 0, 0, 0, 0, 1. And now I can do a couple of things. First, I can verify that this is an REF. I don't have any 0 rows, so I don't need to push any to the bottom or permute them so that they're at the bottom. But each non-zero, the first non-zero value in each row is a 1, and they all appear to the right of the leading one in the rows above. So that is to say, row 3 has its leading one to the farthest right compared to the other 2 rows, and so on and so forth. So at this point, we would say that this is equal to one possible version of an REFA. Yeah? Okay, now at this point, B, we can call out the rank. Since REFA and A, REFA has 3 rows and none of them are all zeros. REF has no 0 rows, and thus the rank of A is equal to 3. The rank of REFA is also 3, but we say that the rank of A is 3. So there's our answer to part B. Now, finally, in this example, we were asked to find RREF of A. And so what we're going to do is very similar to what we had done before with REFA. That is to say, the only other requirement for RREFA is that each one of those leading ones is the only non-zero value in its corresponding column. So if I take this REFA, and I look at my pivot columns, the columns that contain pivots, the columns that contain my leading ones, I have zeros in these positions. That's great. That one in that column is the only non-zero value in that column. But I need to clear out that position, and over here I need to clear out these two positions. That's what I need to do in order to make this an RREF. So, much like I had done with REFA, where I started in this far left non-zero leading one position, I'm going to do the same thing in the bottom over here. I'm actually going to start with this one, and I'm going to clear out the two positions above it. So here we go. This is row equivalent to, now the bottom row is not going to change. 0, 0, 0, 0, 1, and I'm going to change the row above it. And what I'm going to do to get a 0 in this position is I'm going to do row 2 minus 2 row 3s. Again, it's important that you focus on this particular value when you think about zeroing out that position and not this one. Don't use that one. It's this pivot position that you want to use. You're going to grab your pivot and then you're going to pivot with it. And that is going to be my new row 2. And so the middle minus twice the bottom is going to give me 0, 1, 3, negative 2, 0. And then finally, row 1 minus row 3 as my new row 1 will eliminate that last purple one in the top right. And that's going to give me 1, 1, negative 1, 1, 0. So now, this column's cool, and this column's cool originally. I just have to worry about this column and this position here that I want to be 0. So we got one last step to do, and this is row equivalent to, let's see, the bottom row I don't want to change. Everything's fine and dandy there. The middle row's nice now. I got a leading 1, and then a 0 in that last position. And now what we're going to do is we're going to do row 1 minus row 2, and that's going to be my new row 1. Because again, I want to eliminate this position using this pivot. And we have 1 minus 0 is 1, 1 minus 1 is 0, negative 3 minus 3 more is negative 4, 1 minus negative 2 is 3, and 0 minus 0 is 0. And this is RREFA. And that's going to do it for this video.